So guys, the question for today is, what is the minimum required wind speed for small wind turbines? Again, what is the minimum required wind speed for small wind turbines? All the best.
हिलना ना डार्लिंग.
The question for today is, who invented the first alternator? Again, who invented the first alternator? Well, I've removed the wires from the rectifier and I've connected the terminals from the meter directly to the alternator. As you can see that the voltage has increased to 6, 7, even 8 volts. Yeah, 9 volts. Pretty good, guys. Let's hope that we can make it 10. 10 volts, finally. Let's see if we can do 12. Yeah, these are actually all gusts, not a constant wind. So that's why the voltage is fluctuating a lot. Whoa, speed has gained. 11, 12, 12 volts, finally, guys. It is finally producing 13 volts. Wow, 14, even 14 volts. Good for charging batteries, pretty good. Yeah, you can see that is running pretty good. Whoa, I'm going to take the multimeter voltage. 17 volts, as you saw. Yeah, actually its maximum rating is 24 volts and all this is in AC. And I've connected only 2 wires from the AC, and the third wire is not connected because I think the rectifier is not working, some problem with it. Hi guys, you are watching channel Mr. Electron, and today's video is going to be about the repairing of this car alternator, and the defective part is its 3-phase rectifier. You can see that I have removed it. So guys, you can see that I've opened up the back cover that was holding the brushes for the alternator, and this piece is covered with all taping, and these are the wires that are coming out of the alternator. You can see 1 2 3 4 5 6. So I think for star connection, this wire, this smaller wire and this smaller wire, these three will be shorted together like this. At this middle point, you can see some soldering has been provided, has broken out. So these three will be soldered together, and then we are going to have four wires. One is this one, and the second is this final one, which will not be used since this is going to be our center tapping point, and the second one is going to be finally this one, and the third one is this one. So guys, this one you see is the bearing, and you can see there is a little problem with this one. This one is not moving freely, it is jammed, which is another problem that I've found out after I've opened the back cover, and I have to make it more smooth if I want this alternator to work properly and more efficiently. So here I'm placing some WD-40 and hope it works. Okay, yeah, you see it is all smooth now, much more smoother now. Now guys, after giving it 10 more minutes, and you can see that how smooth it is. Initially it was jamming and now it is really free. So this part is done. Now comes the soldering part for the three wires given here, okay? And you can also see that there is a breakage over here. So guys, here as you can see that the soldering part is completed both for this piece and this one. So let's cover it up with this. Here as you can see guys that I'm placing the heat shrink tube, and after that comes the placing of the back cover on the alternator. So guys, for placing the back cover, there is one important thing that we have to consider is to keep the brushes held back in this slot. So here I have this diode, and you see this hole, this terminal of the diode can go through this hole. So we have to place the brush in the slot, push it and keep it held back with the help of this diode terminal, okay? It is much more smoother now. Now all that is left is to connect the three-phase rectifier to the output terminals, and everything else is complete. This what you see is a Vanco KBPC 3510 bridge rectifier, single phase with a maximum current rating of up to 35 amperes. So today in this video I'm going to modify it into a three-phase rectifier for wind turbine generators. So these what you see are diodes, okay, and each diode has a rating of around 6 amperes. So I'm going to use these to convert this single phase into a three-phase rectifier, and with a current rating of up to 18 amperes. So guys, the first step is to make two sets of three diodes, okay, three on this side and three on this side. Let's keep these on one side. Now this gray side that you see, this indicates the negative. So what I'm going to do is connect all the negative sides of these three diodes together, okay? So let's do that. So guys, the soldering part of the first set has been completed. All the negatives on one side and all the positives on one side, okay? Same for this set, all the negatives and all the positives. Now guys, both the diode sets have been completed. Okay, this is the negative side for all the three diodes and same for this one. So let's talk about this set. Okay, so the negative side of this set will be connected to the positive stated terminal of this rectifier. Okay, okay, let's move on to the next one. Now guys, in a rectifier, if this side is positive, then its diagonal opposite is the negative. Okay, so this one is the negative terminal of this bridge rectifier. So to the negative terminal, the positive side of the diode will be connected, which is this side. Okay, gray one is always negative, so the other side automatically becomes positive. Okay, so let's do that. Yeah, positive terminal of the bridge rectifier has also been connected. Now this one and the diagonal opposite, this one, these two are the AC terminals. So we will connect the wires afterwards, but this one to which the diode has been connected and this one to which the other set of the diodes has been connected, these two are the plus and minus output terminals for the three-phase DC rectifier. And since the output current is high, so I'm going to connect the wire of similar rating, okay, to this one and this one. So let's do that. So guys, here as you can see that I've connected the two wires to the positive and the negative respectively, and now comes the time for the three-phase AC terminal connection. The first one is going to be this one at which the diodes meet. Okay, this point, this will be connected first, and to this terminal I'm going to connect the red wire. So guys, now comes the final connection. Okay, let's turn this wire like this. Like this side is going to be the three-phase side and this side is going to be the DC high current output side. So two more wires are needed, which I'm going to use these. So let's take blue one. Doesn't matter which color wire you take, all of them are AC. So you see this terminal, okay, here as I showed you, it's showing the AC sign. So this will be connected over here like this. Done. And this terminal black, this will be connected to the last terminal that is left out. So guys, this red one, black one and this blue one, these three are going to be the three-phase wires. And here as you can see, we have three terminals again. One, this one, okay, second, this one. You see this one is covered, this is not going to be connected, and this is the third one. So we have the three terminals from the alternator and three terminals from this three-phase homemade rectifier. One terminal done. So guys, here as you can see that our alternator is completely ready for testing, and we have a successful three-phase rectifier modified attachment to our alternator. I will have to add an additional excitation power source to the alternator to excite the rotor winding. So here is a power supply that I found in my scrapyard. You see the power rating is 12 volts and 5 amperes, and luckily it is working. Guys, this 12 volts terminals from the power supply will be connected to the brush terminals. This blue one is one terminal for the brush and this red one is the other terminal for the brush. Although polarity does not matters here, but still I'm connecting black to the blue one and red to the red one. You see, the spark indicates the inductive load because it has a lot of coils in it. So I will connect this terminal afterwards. So guys, to the output terminals which are green in color, I've connected the multimeter terminals. So let's point the meter towards DC voltage measurement mode. At present it is showing 2 volts. Yeah, that voltage is because of the power supply interference. You see, I have connected one terminal from the laptop charger, the other is still not connected, but still it is showing some voltage. Winding the thread on the alternator shaft. Let's connect the terminals. Okay, keep watching the display screen. You see it generated around 16 volts DC. Pretty good, right? Now guys, an alternator is supposed to generate a fixed voltage and not go beyond it. Since there is no voltage regulator, so the voltage is high as 16 volts DC. Let's give it one more shot and see how much more I can generate. You see 17.51 this time was the max I could do. Now let's connect a real load. Now guys, the load I'm going to use here is this 12 volts around 5 or 5.5 amperes car headlamp bulb, and this time it is going to be really hard for me to pull the thread because it is loaded. So let's wound the thread. Almost done. Yeah, and connect the left out terminal. Done. Go. Wow. Okay, go. So guys, that's all for today's video. Thank you so much for watching it. I'm going to come with another amazing video related to the alternators, and yes, I also make inverters and more DC motors and generators. So stay connected and enjoy.